This is our Honors 122 Engineering Expo project at Louisiana Tech Spring 2023.
Gotta measure this rope again.
Oh goodness, let me help you with that. Oh, let's do it again. Oh, never mind.
Too bad. We have a solution for this. Using the power of mechanical, electrical, and industrial engineering, we have created the smart cable measure. Let's see how it works. By running rope over this 3D printed piece and having it connected to a rotary encoder, there we go, we can accurately measure out the length of the rope, which is printed out to this LCD screen. And here we can actually see that the rope is about 19.7 inches.
So now that you've seen that it works, how exactly does it work? The way this works is that we have a rotary encoder which allows us to track the rotations of the 3D printed cylinder, and that cylinder has a 2-inch circumference, which means that as it completes a full circle, 2 inches of rope will have passed through it. This rotary encoder communicates with the Arduino, which is our computer or the brain of this, and this sends that output out to the LCD, which displays your current measurement. Now, in addition to this rotary encoder, we have a keypad that allows us to enter different units of measurement, so feet, inches, yards, meters, as well as a desired length, which is, once that is inputted, it goes to the Arduino and then back out to the LCD and is shown on the second row. So this is our software. So the way that it kind of works is that we begin with some initialization stuff, basically just very basic setup, getting wiring set up so that everything can communicate, and making sure all of the commands that we'll need are set up for the code. We then turn on the LCD, and this begins the actual programming part of it. So we move into the Arduino, which is our little computer, looks for basically an input from the keypad, first from the alphabetical side, so basically just choosing your unit of measurement, whether that's inches, feet, yards, meters, like we mentioned previously. From there, it kind of does two different things. It will sit there and read the measurement from the encoder, which is, as you're running your rope through, basically the encoder is telling the Arduino how much has gone through. The signals from the encoder are sent through whatever conversion that for whichever unit of measurement you chose, and then that's displayed on the LCD. While at the same time, the Arduino is looking for inputs from the keypad on the numerical side, so looking for you to basically input your desired length. You can use the asterisk or little star as a decimal place, and then once your desired length is ready, you just hit the pound sign or hashtag, whatever you want to call this fun little button. That enters the actual length into the system, and from there sent to the LCD, and then you just rinse and repeat.
So, sadly, as all things do, this costed money. So, initially, just putting this contraption together costed us $188.50. Whenever we factor in labor, that goes up, and just so we could make money off of the project, we suggest the retail at right under $260, or $259.95 to be exact. The reason we did this is because we expect this to be a product that you can buy once and probably use anywhere between 6 months and 5 years, depending on how badly you beat up on it. But in the long run, you'll probably make the money back anyway, because you really won't be wasting any wire with this product, as well as saving the environment. Because at the end of the day, producing less waste causes less harm.
And here's our final project at the expo.